So here we're going to describe the shape of graphs, and I'm not going to give really detailed, precise definitions. You can look at the textbook for the more detailed definitions, but I want to give more explanations, kind of a starting point, a diving board for conceptually understanding these definitions. So a lot of these definitions are just going to be described with pictures and explanations. So to start, if we're looking at a graph, when I say symmetric, essentially what that means is you can think of the bell curve or something like the bell curve. This is an example of a symmetric graph. I mean, mine doesn't look that symmetric because I don't know how to draw very well. Mine looks a little lopsided, but it's supposed to be symmetric, right? It's supposed to be the same on one side as another. Okay, so this is an example of symmetric data. Another example of symmetric data is maybe we have a bar chart, right? It could be symmetric like this. This is also symmetric data. So a symmetric graph is just, those look like a bunch of buildings that are gonna fall over, but the idea is that a symmetric graph is symmetric, okay? It's the same, like it's reflected on one side and the other. Whereas skewed left has to do with where the tail is. Okay, so maybe we have something like this, has a big tail on the left. It's kind of like we took this picture and stretched it to the left. Okay, that has to do with skewed left. Now it's a little counterintuitive because it looks like most of the stuff is on the right, but just think skewed is where the tail is. It's also, wait, I have to get the right tail. It's also, you can think about it as which direction we're pulling. We're pulling to the left, it's skewed to the left, all right? And this is an example of a continuous one, but we could also draw an example of some discrete data as well. Maybe we could use a dot plot to show another example of data that's skewed to the left. Okay, so maybe we have a dot plot. Maybe it looks something like this. This is an example of data that's also skewed to the left, but this time it's a dot plot as opposed to maybe like a graph like this is supposed to be. And then once you know what skewed left is, you probably know what skewed right is, but we'll go through it anyway. All right, so skewed right is going to be something very similar, where it has this long tail on the right. Okay, and you know, we could also have like a histogram that's skewed right as well. The idea is that there is that tail, that it was stretched to the right. All right. And we also talk about something that has to do with mode. So mode in general, when we talk about mode has to do with things of biggest frequency. If we look at the mode of a data set, it's the number that occurs most frequently. Well, the mode of a graph, when we're looking at the shape, is kind of, you can think about it as the peak. Okay. So if there's no mode, you know, maybe, you know, there's just, maybe it's like all like pretty constant or something like that. We don't really know, like there's not a lot of peaks. It's kind of hard to see, you know, maybe, you know, it just kind of looks like, you know, there's not really a lot of peaks. That doesn't mean it's completely flat. Maybe it's not completely flat, but there's no like single peak. There's no single like kind of maximum. Whereas unimodal, while an example of a continuous graph could be that normal shape, that bell curve we were looking at before, there is one peak. All right. And now this doesn't necessarily mean like there's, like this can be a little flexible. So like here over here, wow. I'm going to draw a histogram of something else that's unimodal, but it doesn't mean like, it doesn't have to be like a perfect definition. So if as I'm drawing this, right, we would say this is unimodal, even though if you really look, right, if you really look, you know, this one and this one are a little higher than the ones next to them, right? But there's still a pattern that, yes, it's going up and then it's going down. Okay, it's kind of all building up towards one peak. Just like if you look at Rainier, maybe Rainier is a bad example, but Mount Rainier kind of, you know, it's not perfectly smooth, like there's ups and downs, but it's still one mountain. Okay, it's kind of one way to think about it. And then similarly, unimodal is one peak, bimodal, you guessed it, is going to be two peaks. Okay, so maybe we have something like this. So there are two very prominent peaks. Has to do with their prominence. Okay, over here, there's only one prominent peak, even though there are baby peaks. And then over here, it's going to be like two prominent ones. So again, maybe we have dot plot, kind of like this. This would be another example of bimodal data. And then multimodal is just going to be more than two peaks. So it's kind of interesting, right? Multimodal and no mode can kind of look similar sometimes. But yeah, maybe we'll have something like this. Here's kind of three prominent peaks, or etc. So last thing I want to mention for this video is outliers and subpopulations. So outliers are often maybe a recording error, or sometimes just like excessively unusual. All right, and we'll talk more about what it means to be an outlier and how to find outliers in future videos, but just in general, that's something to be aware of. So, you know, maybe we're looking at maybe we're looking at exam scores, right? Maybe we're looking at exam scores, and you know, like most of the people got like a 40% on an exam. But then there's that like one person that got like a 90 or something. You're like, how did you get a 90? This exam was like the hardest exam we've ever taken. And they're like, oh yeah, I didn't even study, or something like that, right? Or, you know, we could see this kind of as a dot plot as well. You know, maybe most of it is concentrated somewhere, but then there's like random person up here. Or it could be the other way around. Maybe everyone did pretty good on the exam, and then there's that one person, and it's like, I didn't even know we had an exam. I don't even know what class we're in. Maybe they showed up to the wrong class. Who knows? All right, but we're going to think positively for these outliers. Okay. And the last thing is subpopulations. Sometimes when we're looking at a distribution like this, or a graph, maybe the population can be kind of divided into multiple groups. So for example, if we're looking at the height distribution of people, well, then it kind of makes sense, right? There's going to be kind of one height distribution for men and one distribution for women. Those are subpopulations. Okay. So I'm not going to mention too much about them, and I'm not even going to bother writing anything down here, but something to be aware of. You can read more about that if you want. And that is this video on describing the shapes of graphs.